Have you ever had the desire to build an interactive command line interface from scratch using JavaScript? In today's video, we will build an interactive command line interface to interact with the blockchain and P2P network we have built in our previous videos. What if I told you that the command line interface is the most critical and most totally overlooked part of any real-world blockchain node? That's right. Why everyone's obsessed with cryptographic hashes and consensus algorithms, the CLI is the central nervous system that ties everything together. A poorly designed CLI means your blockchain is going to be practically unusable. In this video, we are building the engine room of our Netchain node. We are going to architect and code a professional grade CLI from scratch. This isn't just about printing to the console. We are building the mission control that will let us create and manage secure encrypted wallets with a single command. It's going to allow us to send transactions by name, not just by cryptic addresses. It's going to allow us to mine new blocks, collect rewards, broadcasting them instantly across the P2P network. And finally, it's going to allow us to interact with the entire blockchain in real time, from checking the supply to diagnosing the network's health. If you've ever wanted to understand how the tools like geth or bitcoin-cli actually works under the hood, this is your backstage pass. We are moving fast, and by the end of this video, you have a fully functional interactive blockchain CLI that you can actually use. If that makes sense to you, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification so you can get access to all of our videos as they drop. Please leave your thoughts on the video in the comment section. If there's anything I missed with this implementation or a feature you think would make the CLI more robust, then I would absolutely love to hear from you. Let's dive into the code for today's video. I will define a new class, BlockchainCLI, and on that class, I will define an RL property, which stands for readline. This is our connection to the user's keyboard and terminal screen. This is how the CLI talks to the user. It allows the program to display the prompt Netchain, listen for what the user types, read the text when the user presses enter. Any method on the CLI that needs to ask the user for input, like the send method asking for a password or displayed a message, we use this RL property. Next, I will declare a private blockchain property which holds a reference to the main blockchain ledger. The CLI doesn't contain the blockchain logic. The CLI, we need to ask the blockchain object to get balances using the get balance of address method. It will need to ask the blockchain to add transactions using the add transaction method. The CLI will also need to ask the blockchain object to mine blocks and check if the chain is valid. Every single command that interacts with the blockchain, like get balance, send, mine, print chain, we need to call methods on this blockchain object. Next, I will define a private P2P server property which holds a reference to the peer-to-peer networking component. This is needed for network communication because the CLI needs to tell the network about new transactions or mined blocks, so other nodes can know about them. There will be commands that involve sharing information with the network, like send, mine. The CLI class will use this P2P server to communicate with other nodes. Next, I will declare a private wallet property which maps a name to a cryptographic wallet. When a user creates a wallet using the CLI, let's say create wallet Alice, we will need somewhere to store that wallet inside of the CLI session. Later, when the user wants to send money from Alice, the CLI can quickly find the actual wallet object by looking it up in this.map using the name Alice. Next, I will define the constructor function which accepts two arguments, a blockchain, which is the ledger, and a P2P server. This is because the CLI needs access to an existing blockchain and a P2P server network to work with them. Inside this constructor function, I will set this.blockchain to be equal to the blockchain argument, and I will set this.p2p server to be equal to the P2P server. Then I will create a new empty map object and assign it to the wallet property. Next, I will create a readline interface by calling readline.createInterface. This is a factory function that creates and configures a new readline object with a config object. The input will be the process.standard input, which means read from the standard input, which is the user's keyboard. The output will be process.stdout, which means write to the standard output, which is the terminal screen, and the prompt will be netchain. This sets the text that appears before the cursor where the user types. This creates and configures the tool that allows the CLI to interact with the user. It sets up the familiar command line experience with the Netchain prompt. Next, I will call this the setup event listener method, which will be implemented shortly. But first, we need to implement a start and a stop method for the CLI. I will implement a start method which initializes the user experience when the CLI first launches by informing the user that the CLI is now running and ready, providing guidance by suggesting they type help to see available commands. Then I will call this the rl.prompt, which displays the command prompt Netchain to the user and signals readiness, telling the readline interface to show the cursor and wait for user input. This is because when user runs the program, they need to know it's working and what they need to do next. The rl.prompt method is crucial because it is what makes the terminal actually wait for the user to type something. Without this, the program might start but not show the prompt immediately. Next, I will implement a stop method which gracefully shuts down the CLI by calling this.rl.close. This closes the readline interface and stops listening for user input. It triggers the close event that we are going to set up in the setup event listeners method and prepares for program termination. It ensures the CLI doesn't keep running in the background when it should stop. Next, I will implement the setup event listeners method, which is the central nervous system of this CLI. This method registers callbacks that responds to specific events happening in the readline interface. Think of it as setting up an alarm system or switches that activate when certain things happen. Next, I will listen for a line event on the readline. The line event is an event type that fires when the user types something and presses enter. Inside the listener, this function runs every single time the user presses enter. First, we will receive the input because the line parameter contains the entire text the user typed. Then I will process the input by removing any extra spaces at the beginning or end and splitting the text into an array of words using space as a separator. So send Alice Bob 50 becomes an array of send Alice Bob and 50. Next, I will extract the command by taking the first word from the array, which is send in this case, and converting it to lowercase. This makes the CLI case insensitive. Next, I will extract the argument by taking all elements from the array except the first one. These are the parameters for the command. Next, I will execute the action by calling a separate method that contains the logic for handling different commands, passing the pass command and arguments. This method will look what send means and actually execute the appropriate code. Next, I will show the prompt again. This signals to the user that the CLI is ready for the next command. Without this, the prompt wouldn't reappear and user wouldn't know the CLI was ready. It's the mechanism that turns raw user text into meaningful actions. It makes the CLI feel responsive and interactive. Then I will listen for a close event on the readline. The close event is an event type that fires when the readline interface is closed. This usually happens when the user presses Ctrl+C or Ctrl+D or when the program is terminated. This function runs when the CLI is about to shut down and it provides feedback by using console log exiting Netchain CLI. It also shows a friendly goodbye message and it terminates the program using process.exit with 0. This forces the Node.JS program to stop running. This ensures that the program ends cleanly instead of hanging. It also informs the user that the program is shutting down and it prevents the program from running in the background. Next, I will implement the execute command method. This method will accept a couple of arguments. Command, which is the command we want to execute, and args, which is an array of arguments. This method is the decision-making center of the CLI. Think of it as the main switchboard that routes incoming calls, which is user commands in this case, to the appropriate departments, which are the specific methods to handle that command. Inside the method, I will add a switch statement which checks the command passed in, which is a decision tree that checks the command and calls the appropriate method to handle that command. First, we will handle the help command. When the user types help, call the show help method, which displays all available commands to the user. We are yet to implement that method. So let's pause first and implement that show help method. When the user types help, the show help method will be called. This displays all available commands to the user. We will come back to the execute command method because we have so much more commands to deal with. The show help method is the user manual generator. This method is the built-in documentation of the CLI. This method displays a formatted list of all available commands and their usage. I will add a console log that uses template literals. I will add all relevant commands starting with the help command. Then I will add the create command followed by the list wallet, get balance, send, and mine commands. I will also add the print chain command, the add node command, the list node command, the connect command, the status command, the supply command, and the exit/quit command. If I run this app from the terminal again by creating a blockchain and using the blockchain to create a P2P server, then starting the P2P server and using that blockchain and that P2P server to create a CLI, which I will then start, you will see that the app is up and running. If I type help in the terminal, you will observe that the list of all possible commands show up. Now, let's implement another method that will handle the create wallet command. We will implement the method first and add the command processing inside the execute command method. The create wallet method is the digital wallet factory. This method is the wallet creation workshop of the CLI. Inside the method, we have to first handle input validation to ensure that the user provided at least a wallet name by checking that the args array has at least one element. And if not, we will show the correct usage syntax if the validation fails, and I will return stop execution. The next step would be to extract the parameters. The first argument becomes the wallet identifier, and the second argument, that is if it is provided, is used for encryption. The password might be undefined if it is not provided because it is optional. The next step is to create the wallet instance. I will call the wallet class constructor to create the wallet. The next step is to register the wallet. First, inside the CLI storage with this wallet.set with the name and the wallet. This stores the wallet in the CLI's internal map. Then comes the blockchain registration using this.blockchain.register wallet name to link user-friendly name to the blockchain address. This is a two-system integration that makes the wallet accessible both locally on the CLI and globally on the blockchain. The next step would be to display wallet information by showing that the wallet was created successfully with the blockchain address. We will also display the mnemonic phrase and emphasize on the importance of securing this phrase. The next step would be to handle the encryption status of the wallet using a conditional message that only shows if a password was provided. Lastly, we will log out any errors encountered in the error block. Now, let's register this command on the execute command method, then go ahead to test it out. I will type help in the terminal to see the syntax for wallet creation, and then I will create a wallet, Alice. You can see the address and the mnemonic phrase in the terminal. I will create another wallet, Sam, and you can see the address and the 12 key phrase. Now let's go ahead and implement the get balance method. This method is the balance checker of the CLI. This method retrieves and displays the correct balance of a specified wallet, either by its user-friendly name or its cryptographic address. First of all, we have to handle user input validation, ensuring the user provided a wallet identifier, which might be the name of the wallet or the address of that wallet. We are going to show correct usage if no argument is provided and stop the execution if validation fails. The next step would be to retrieve the address from the user input. Then we have to handle name resolution by asking the blockchain, does this name exist in your registry? If the user typed Alice, it checks if Alice is registered. If the resolved address exists, that it is not null or it is not undefined, it means the input was a name, and then we have to replace the original address with the actual blockchain address. If resolved address is null/undefined, that is, the original address was an actual address and it is going to remain unchanged, then we can fetch the balance by querying the blockchain to calculate the total balance for the resolved address. We then display the results by dividing the retrieved balance by 1000 because the blockchain stores amounts in smaller units. The next thing would be to register this command on the CLI via the execute command method and test this out from the terminal by first creating a wallet Alice and then checking the balance of Alice, which is correctly 0. Now let's implement the mine method. This method is the block miner of the CLI. The first step is the user input validation, where we ensure the user specified who should receive the mining reward. If there is an error, we show correct usage if no miner address is provided and stop the execution if the validation fails. The next step is address resolution, and this is exactly the same as what we did in the get balance method, which supports both wallet names and addresses as miner identifiers. We will convert the miner wallet to an actual blockchain address if it's a registered name. The address will now contain the target blockchain address for the reward. Then I will add a try-catch block to start the mining process with error handling. I will inform the user that the mining process has begun, and this provides immediate acknowledgement of the command. Then I will call the blockchain's mining method, which takes all pending transactions from the pool and it adds a mining reward transaction to the specified address and creates a new block with these transactions. And then it performs the proof of work calculation, that is finding the correct nonce, and adds the completed block to the blockchain. The next step would be network broadcasting, where we inform all connected peers that a new block was mined. The next step would be to add a completion notification with a success feedback, which confirms that mining was successful, and it also informs the user that the blockchain has been updated. The last step is error handling with a safety net that catches any error caused during the mining process, gracefully handling any failure, showing an error message instead of crashing the CLI. The next would be to register this method on the execute command method. Test this out by creating a wallet, mining a block with the newly created wallet. The next command we need to implement is the print chain command, which allows us to see the length of the longest chain. I will add a print chain method which displays the entire blockchain structure in readable format. This allows for debugging and inspection of the complete blockchain state. Inside the function, I will convert the entire this.blockchain object to a formatted JSON, which shows all blocks, transactions, and their details for analysis. And then I will register the print chain command on the execute command method, which I will test out by creating a wallet, mining a first block, and executing the print chain command. Next, I will add a new method, add node, which adds a new peer node URL to the blockchain's network registry. It expands the network connectivity for synchronization and transaction sharing. This method takes a URL argument and stores it in this.blockchain.nodes set. This will enable the blockchain to communicate with more nodes in the network. Next, I will add a list node method which shows all known peer nodes in the network. This provides visibility into the network topology and connectivity. We will also convert the blockchain.nodes to an array and display each node. This will show which other blockchain nodes this instance knows about. Next, I will add a new method, connect to peers, which accepts an argument, which is an array of strings. This establishes direct WebSocket connection to specified peer node. It actively connects nodes to exchange blockchain data and transactions. This passes peer URLs to the P2P server.connect to peers method to initiate connections. This will create real-time communication channels with other blockchain instances. Next, I will add a show supply method which displays cryptocurrency supply information. This shows the economic state and progress towards the maximum supply cap. This calculates and displays total, remaining, maximum supply, and percentage progress. This will show total/remaining/max supply in net coins and percentage of completion. I will also add a show status method, which is the blockchain's health dashboard. This method is the system overview of the CLI. Think of it as the dashboard that shows the overall health and key metrics of the entire blockchain network. This method aggregates and displays the most important health metrics of the blockchain system in one comprehensive view. This provides provides a quick snapshot of the blockchain's current state. It helps identify potential issues like invalid chain or high pending transactions, essential for network administrators and users. I will log out the block count, which shows the total number of blocks in the chain. I will also log out the pending transactions, which show how many transactions are waiting to be mined. I will log out the difficulty, which shows how hard it is to mine a new block, which affects the mining time. I will also log out the mining reward, which shows the economic incentive for miners. I will log out the chain validity. This is a critical check. Is the blockchain corrupted or tampered with? I will also log out the node count. This shows how many other blockchain nodes this instance knows about. I will also log out the total supply, which shows how many coins have been mined so far. I will log out the remaining supply, which shows how many coins can still be mined. Next, I will add a send method, which is the transaction creator and broadcaster. This method is the payment processor of the CLI. Think of it as the secure payment terminal that creates and broadcasts cryptocurrency transactions between wallets. This method creates and broadcasts a cryptocurrency transaction from one wallet to another, handling both named wallets and direct addresses. First of all, we have to handle input validation. This ensures that the user provides sender, recipient, and amount while showing the correct usage format and stops execution if insufficient arguments. The next step would be to extract arguments, which is the from, to, and the amount, and then we convert the amounts to base units. We have to resolve the from address and the to address. Next, I will find the sender's wallet, then I will validate the wallet existence. I will securely ask for wallet password without showing it on screen. Next, I will create a signed transaction using the wallet's private key, and I will add the transactions to the local blockchain spending pool. Then I will send the transaction to other nodes on the network. Next, I will use the commander.js library to create the main command line interface for the entire application. The purpose is to create the main command parser with version and description. Next, I will add the start command, which launches the full blockchain server with CLI, allows specifying port and peer connection, and initializes all components and starts the interactive CLI. Next, I will add the create wallet command, which is a wallet in isolation, that is standalone node. It requires a name, an optional password to create a wallet, and displays details without full blockchain setup. Next is the program execution, which passes command line argument and executes the appropriate command. The default behavior shows help if no command is provided. All you have to do is run this file from the terminal to begin interacting with the blockchain from your terminal. If that makes sense to you, then absolutely smash the like button. Ensure you subscribe to the channel and turn on the bell notification so you can get access to all of our videos as they drop. Please leave your thoughts on the video in the comment section. If there's anything I missed with this implementation or a feature you think could make the CLI more robust, then I would absolutely love to hear from you in the comment section, and I will see you in the next one.